Hi, my name is Andrew Allen, and I will be going over the data set for our group. Our data set includes 20 years of data on video games regarding the release date, platform, and rating. We were interested in this because most of our group had interest in gaming, and we're curious to see the trends involved with this data. We wanted to answer some questions, mainly the average game rating per month, whether the platform exclusivity has any bearing on ratings, the average rating of game genres, release date and rating correlation, and the month the best games were released. So we'll move on over to MATLAB. And the first file is called import file, and this is basically all generated by MATLAB, and it allows us to generate a function to import all of our data. This next file is make matrix. So basically what we're doing here is taking all the data from import file, the inputs, which I should say, and put them in new matrices, one for the numeric values and one for string values. And then we can go on to user input, and this is basically our main menu, where we use a while loop and a switch case to create our menu. The switch cases are for each part of the menu. So we have scatter, plot, slash line graph, bar graphs, pie chart, lookup item, histogram, and end. So this makes up our menu. And then we can move on to project main script, which uses the import file, make matrix file, and our menu file, which is our user input. And this, once you run it, starts up our menu and allows us to run through all of our graphs and everything. Now we'll go to scattergraph, which is the file that I wrote, or function, I should say. So we take our make matrix inputs and use that as our input for our function. And then we create our menu and then use a switch case for each part of the menu. So after doing that, we have this else if statement, which compares the inputs for month and year to our data set and finds where these two inputs exist together and places the data in a variable called new score matrix. And then this graphs our first scatter plot right here. And then for case 2, this compares the score for an input year. It does basically the same thing as the first case, but for the year. So it checks through all the data and stores these values in new score matrix. And then we also plot this as a scatter plot. Case 3 will compare the scores for one specific day. So there's an if statement all the way down this. Okay, so case 3 pretty much does the same thing as case 1 and case 2. Again, the code are pretty similar. But we also have this if statement down here, which if true, displays that there were no games released on this day. And this is just if we came to a day where there's really nothing released, and it will prompt the input, or prompt the user to input something else. And then here's our graph again, and this is actually a line graph. And then case 4 will return us to the main menu. Now we can move on to our pie graph. So we create our function, and then create a menu, and use a switch case for this. Our case 1 will compare we'll compare each genre. So we see that this k, we set that equal to our string matrix. And if k is equal to one of these certain genres, it will add to this counter and it will be stored for our pie graph. And this is all of our code for creating the actual pie graph. Case 2 is actually a nested case where the first case, this case actually shows all the platforms. First case shows all platforms together, and it's similar to the very first case outside of this nested case, where our K2, if it's equal to one of these platforms, it'll add to this counter, their individual counter, sorry. And then this is, again, the code for the pie graph. Case 2 in the nested case does the same exact thing, but for all the PlayStations. Case 3 does it for Nintendo consoles, and case 4 does it for the Xbox. And then case 5 simply returns us to our main menu. Case 3, outside of this nested case, is for the editor's choice. So if this value, or if this variable case 6 is equal to y, this means it's yes, it's an editor's choice. It'll add to this counter and keep track of that for a pie graph. And here is the code for the graph for that pie graph. Case 4 represents our score phrases. We have another nested case in this case for all phrases used, positive phrases and negative phrases. Again, initialize these values and then use this variable case 7 to determine if it's equal to one of these score phrases, it'll add to the counter. And then we again graph it for a pie graph. Case 2 does it for the positive score phrases, and then case 3 is for all of the negative score phrases. And case 5 returns us to our main menu. Now we'll move on to our lookup function. So we make a function again, just like the other ones, and then use a menu and a switch case for this. Our first case is for looking up any game in our data set. So we use a for loop and an if statement that searches through the games until it finds the one that was input. Another if statement right here will display if there was no games found. And then for case 2, this is for release month. It returns the games released in this month and searches for the title and all the data that's involved with it. Again, similar to case 1. Case 3, right here, this is for if the user inputs. This allows the user to input a genre. And it'll search through all of our data, check to see where this genre matches up for each game. And if the genre matches up to the game, it'll display all of these games together as one genre. Case 4 is for platforms. it does the same thing as case 3, but for platforms, obviously. Case 5 and 6. No, sorry, just case 5. Case 5 does the same for score phases. Case 6, move down here. This is a nested case. And what this will do, you'll be able to choose a platform, and it's going to show you the number of games for each platform. So the first one is for Nintendo consoles, second is for Xbox, third is for PlayStation, and fourth is for PC, and 5 is for mobile. So what it's going to do, it's going to take this variable PLAT, which is short for platform, and see where it is equal to each of these platforms, and then add to the count to keep track of the number of games. And then case 6 will return us to our main menu. Now we'll move on to our next file, which is our bar graph. Again, we create our function and use a switch case for this. Our first case, we initialize all our values for all the years. And then, so it searches through all the data using this nested for loop and sees where all the data matches up for that certain year and increases the count for all of these iterations. Sorry. And then down here, we take the mean for each of these new vectors that were saved up here and score them, and put them in a new vector. And then this allows us to create a graph. For case 2, we're looking for the average score per month for a given year. So we initialize all of our months to be 1, and then we create these empty vectors right here, just in case there's no games released in one of these given months, so it's able to handle this without erroring out. And then again, we use this for loop and if else statements to compare all the data. Case 3 gives us the number of games released by month for a certain year. So again, we initialize our values, and then this for loop will search through all of our data and then add to the counter where it finds the correlating data. And then here again, we have our graph. Case 4 that shows the number of games released by year for our entire data set. And again, it's similar to the other cases. Most of the code is pretty similar. Again, the graph, and also our curve fit right here for all of our games released for all the years. So we're able to see if there's any correlation, or we're able to see where future years might be for game releases. And then case 5 returns us to our main menu. Lastly, we'll move on to our histogram. So we initialize all of our scores, and then this for loop with an if statement in it checks if the score is between these certain values, like between 0 and 1, 1 and 2. And if it is, it adds to the counter. Once all these values are stored, then all these values are stored in a new matrix, so we were able to graph our histogram. Now I'll run through our entire menu and show you all of our results. So we'll first go to scatterplots and go to score versus release month. And it'll prompt us for a month, so I'll enter November, and then 2003, for example. And then we're showing our scatterplot, and we're given this output as well. Now we go back to scatterplot, go to score versus release year, and I can enter any year. And again, it'll return us a scatterplot. Going back to scatterplot, we can go to score versus release day, which is our line graph. So I can enter, say, 28th of November, 2012. And then this gives us our line graph. Now we can move on to our bar graph. So for the average score per year, there's no input for this. It simply returns our bar graph. And it shows the highest average score out of all the years. Go back to bar graph and go to average score per month for a given year. So we input a year, let's say 2008. And again, we get our monthly scores for that year. Back to bar graph again, we can see the number of games released by month for a given year. So let's say we do the year 2004. And that shows you the number of games for each month in that year. And then finally, for bar graphs, we can see the number of games released by year for all of our data. And there's no input for this except for seeing what future years could hold. So we're prompted to enter another year. So I can say 2018, for example. And here's our projected number of games right here. Now we move on to pie chart. So we can see each genre share of the market. So this is percentage of games right here. There's no input for this though. It'll take a minute to load. And here's our pie chart. We also could see each platform share of the market. This will pull up with the nested menu right here. So we can see major platforms. Right there. Go back to bar graph. Oh, sorry. Go back to pie chart. Each platform, PlayStation consoles, and so on. It does the same thing for each platform. So then we can move on to editor's choice. And this is a simple pie graph. It's yes or no. And then score phrases, which pulls up another nested menu. I'm just going to show one because I don't want to go over the time limit. So we'll go to all phrases used. And along with the pie graph, you can see we output a table down here to see the number of score phrases for each one. I think that was it for the pie graphs. Yep, so return to main menu, and then move on to lookup item. So I can search any game of a name, so I can do, let's say, NHL 13. And it'll give us all the data for that game. Going back to lookup, we can do the release month. So I can enter a year, and let's say November. And it'll show you all the games released for that month and that year. Back to lookup, we can go to genre, and let's input a genre. This will show you all the games in that genre. And then we can move on to platform. Let's say the Xbox 360. And we're given all the games for the 360. Then we can do score phrases as well. Let's do painful. And we are outputted all of the games that were rated painful by IGN. And then lastly, major platforms. This is another nested menu. I won't go through all of them, but for example, here's Nintendo. And these just simply show the number of games for each of these. So lastly, we'll move on to our histogram. And again, there's no input for this, but it shows us our histogram graph and the number of games for each rating. So we'll see there's very few 0 to 1s and very few 9s and 10s. So in the end, we were able to answer some of our questions. We found the average game rating per month using our bar graph. However, we did not find the average rating of the game genres. And we found that there was really no correlation between release date and rating, but we were able to find the month for each year where the best games were released. So in conclusion, this project helped me better understand writing code. Honestly, I was a little lost in the previous engineering class with the Lego robots, but I feel like I learned a lot in this class and helped give me a better understanding of coding. I'm now able to read and write code much more effectively after this project. Just working with the team and learning from all of them and having their support was very good for this class, I think. The problem solving helped me understand MATLAB much better, and I think I honestly learned a lot more than I would have trying this on my own. So that's my presentation on our data set.